This is the next video for trig differentiation. Okay, and in this video we're going to look at what we get if we differentiate inverse trig functions. Now, the formula for differentiating inverse trig functions is in the formula book, but it is in the further maths section. So if you are asked in your A-level to differentiate one of your inverse trig functions, arcsine, arccos, or arctan, remember those, that's sine to the -1, cos to the -1, or tan to the -1, your questions will be of a certain form. They will be show that's. Okay, now to speed us up, I've just written what the formula are at the top. So I'm going to have a little look at differentiating arcsine and arctan, and arccos, you notice, is practically identical to arcsine apart from the negative. Okay, so I'm going to prove the first one, or I'm going to do the first one. Okay, so imagine the question said, show that if y equals arcsine of x, then dy dx is 1 over the positive square root of 1 minus x squared. Okay, so I'm going to start with y equals arcsine of x. Now I'm going to rearrange it. So it would be x equals sine of y. So what you've done is you've signed both sides. Okay, remember that sine of arcsine of x is x. Then we're going to differentiate, so we get dy dx equals cos of y. Therefore, dy dx equals 1 over the cos of y. Now I'm going to change colour because I'm now going to use a trig identity. And the trig identity I'm going to use is cos squared y plus sine squared y equals 1. Now, I'm going to rearrange that to get cos squared y on it. It's cos y on its own. So cos y equals plus or minus the square root of 1 minus sine squared y. Okay. Now, what you'll first of all you'll notice that sine squared y, I've got x equals sine y, therefore sine squared must be x squared. So cos of y equals plus or minus the square root of 1 minus x squared. Now, if you look at the formula at the top, you will notice up here, the square root that we've got is the positive one. Now, that is to do with the gradient of the arcsine graph. Now, if you draw the arcsine graph, you will notice it's an increasing function, and therefore its gradient is always positive. So we then just take the positive one. Okay, so therefore dy dx equals 1 over the positive square root of 1 minus x squared, as arcsine of x is an increasing function. Okay, now you'll notice that the arccos one is practically identical. That's when, so you do it the same way, but you rearrange your equation to get sine y equals plus or minus the square root of 1 minus cos squared y, which gives you plus or minus the square root of 1 minus x squared. But think about the graph of arccos. Now, arctan, again, slightly different. I'm going to do that one over here on the right hand side. So I'm going to get, so y equals arctan of x, therefore x equals the tan of y. So dx dy equals sec squared y. Okay, so dy dx equals 1 over sec squared y. Now, if you remember, and again I'm going to write my trig identity in a different colour, okay, sec squared y equals 1 plus tan squared y. And if you look here, you can see if x equals tan y, then x squared is tan squared y. So therefore, okay, dy dx equals 1 over 1 plus x squared. And that is your rules for differentiating your arctan, arccos and arcsine. Now, if you get one of these in the exam, it will say show that, and then it will say hence. So it might say something like hence differentiate y equals 2 arccos of 4x. So we're going to do that one, just that one. So remember, arccos from above, if y equals arccos of x, then dy dx equals -1 over the square root of 1 minus x squared. So what have we got to be careful of? Well, we haven't got x, we've got 4x, and we've got a 2 at the front. So this is what we're going to have. So we've got dy dx equals, okay, so I'm going to get -2 over, so I've got the 2 at the front, the square root of 1 minus, now we haven't got x, we've got 4x all squared, and then we need to differentiate inside. Okay, so we get the 4 there, so you'll end up with -8 over the square root of 1 minus 16x squared. Okay, and that is that video.